Everyone, welcome back to our channel. Today we are going to find the solution for the problem number 38. Obtain transfer impedance for the parallel RC network. You can see here all the resistor and capacitor are in time domain. Let's try to transfer this into frequency domain. Okay, so now how to solve this value is actually this also should be in the time domain. So now I'm transforming only this r in time domain and transforming to frequency domain. Okay, so therefore the network will be like this with one resistor and another is also an resistor. Okay, so this is of 1 ohm. So here the formula for converting and resistance to capacitor is 1 by SC. There is nothing but 1 by S into 1, which is nothing but 1 by SC ohms. Okay, and this is the input voltage V1 of S with an input current of I1 of S. And you can see here these two are in connected in parallel. Okay, so whenever these two are connected in parallel, I can say that it's like a small resistor connected like this. Okay, so this is V1 of S, this is I1 of S with an output voltage of V2 of S. The voltage at this point will be available at this point, which is V2 of S. Okay, so what is this resistor value is these two are connected in parallel. Therefore, the formula is when two resistors are connected in parallel, 1 into product of resistance divided by sum of resistance. Okay, so this I can write on it as 1 by S and take the S as an LCM. So this is S plus 1. So S will get cancelled and you are going to get 1 by S plus 1. Okay, so this is the value of this branch after solving it, 1 divided by 1 plus S. Okay, so now I need the value of V2 of S divided by I1 of S. Okay, so the current which flows in this branch is also same I1 of S. Okay, so now try to apply nodal analysis at this point. Therefore, I1 of S is equal to V2 of S minus 0 divided by 1 by 1 plus S. Therefore, we require V2 of S divided by I1 of S is equal to 1 divided by 1 plus S. Okay, so this is the ultimate value where V2 of S divided by I1 of S is called as transfer impedance. We can study this in two-port network: transfer forward transfer impedance. Okay, so this is the value of forward transfer impedance. If you feel my explanation is good, please like the video and share with your friends. Still, if you have any doubt, let me know in the comment section how to convert all this. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasiram. Kindly support this sort of free channels for the development of students and faculty. Thank you for watching. We'll meet in the another video. Viewers from